Alright, well, this is a bit of a funky setup, but we're gonna do 35 minutes of looking at this SL paper 1, just trying to spread through it as fast as we can. Maybe not spread through it, but we're gonna go for 35 minutes. I've never looked at this paper before. This one is saying that it's written to take an hour and a half, and it is 80 marks. So more or less 1 mark a minute, a little bit different, but I'm just gonna put them in there, I guess. Probably a good idea to read some instructions. Full marks are not necessarily awarded for a correct answer with no working. Answers must be supported, of course. Of course. Show all answers in the box provided. All right. Up first, we've got f of x and g of x. And we need to find the derivatives. Should be pretty straightforward. Cosine 4x, the derivative of f. I'm thinking that the derivative of cosine is negative sine. I'm also thinking that it does have an interior function. So I'm going to need to make sure that I either use chain rule and do the whole use substitution strategy, or this one's really quite easy. It should be negative 4 sine 4x, because the derivative of the inside is 4x, is 4, so the 4 comes out front. So nice, that's getting me 2 points, I guess. 2 marks. B, g prime of x. I guess I'll just write g of x first, although they're not that different. G prime of x, same thing, take the derivative of the top. The derivative of the top is 3, and put that 3 out front. Now the regular derivative for e to the x doesn't change, so pretty much the same thing going on for the second one. Again, just popping out the constant, and pretty easy so far. 2 quick. I definitely don't mind the test. It gets started with 4 easy marks for me. Again, you could use u substitution. U equals 3x minus 1, du equals 3, and then do your whole swapping where then we write e to the power of u, and I think we'll be okay. Getting down to C, let h equals g of x times f of x, find h prime. I'm thinking that even though this looks complicated, this is just telling us to multiply g and f together and take the derivative when they're multiplied together. That tells me that I need to do product rule. Now if I write it like this, h of x equals g of x times f of x, h prime of x is equal to, and do my product rule, which is leave one alone, take the derivative of the other, plus, then switch it around, derivative of the other, and then leave this one alone. I have all of these values. I have g of x from the question, I have f prime from part A, I have g prime from part B, I have f of x from the question. So now all I need to do is plug these things in, and I've already got all of them. So g of x is e to the 3x minus 1, f prime is negative 4 sine 4x, plus g prime 3e to the 3x minus 1, and f is cosine 4x. I didn't really have to do anything new for this question. I've just been writing all these things in, and maybe tidying up could get me 1 extra mark, and it doesn't seem like it's going to take me that much to do, so I'll do that next. I'll probably put this negative 4 sine 4x piece first, put the 4x in parentheses to make sure it looks like it's the sine of 4x. Follow that with a times 3x minus 1. I guess that, honestly, I'm not really doing anything, so maybe this is a waste of time. Plus cosine 4x times, I could slide this 3 in front, e to the 3x minus 1. Again, I don't know that that's actually simplified it or made it look that much better, so probably a waste of my time. But I still feel pretty good that I'm getting all 6 marks for this question. Yeah. When I noticed that this was only 2 marks, I knew I really wasn't going to have to do very much math, so not too bad. 7 different plants studied in a biology class. For each plant, x is the diameter of the stem, centimeter, averaging the centimeters. R being Pearson's product moment correlation coefficient. Cool. A, write down the possible minimum and maximum values for R. I think that just means in general. Right, I mean, the values for R are from -1 to +1. If you're -1, then you're a perfect negative correlation, and if you're a +1, you're a perfect positive correlation. In fact, B looks like a +1 and E looks like a -1. I think this is all that we need. I guess it does say minimum and maximum, so maybe it's better if I write it out. Minimum value -1, but I think this is probably also a waste of time. I think our notation before is better. That was easy. 2 marks. Part B, copy and complete the table by notating A, B, C, D, or E. -1, -0.8, 0, and 0.5. This should be pretty easy, and I love that it's 4 marks. I'm just getting marks for matching it up here. One thing I could do is go through and I could say, this one looks positive, this one looks positive, this one looks negative, this one looks negative, this one looks bad. I could say this one looks good, this one looks good, this one looks okay, this one looks okay. And now when I look over here, it's, I think that's probably a waste of time to write, because you can probably just do this in your head. -1 is a perfect negative. That's got to be E. We even mentioned that earlier. -0.8 is still negative and quite good. So I think that's quite okay, I guess. That's going to be A. 0 is going to be our bad version, which is C. And 0.5 is not going to be our perfect. It's going to be D here. So I got EACD. Again, 6 marks. We're out of here. That's an easy one. Oh, I need my formula booklet. All right. Not too bad. I think we got 12 marks. I think it's been 8 minutes, so maybe we're ahead of schedule, plus all the introduction stuff. It's totally okay. Oh, this is an easy. This is the IA grade paper. Who was it? Colin or Diaz? Is that my last one? I had one. Here it is. I knew I had one. All right. What a great. We're on the clock. Come on. Yay! Welcome. It is good to see you. We are going through. Another piece of paper that I printed out. Right, you can be the answer guy. Make sure that we're getting it right. It's totally okay to have strengths and weaknesses. Stats and probability is the only class I've never taught before, and I'm gonna have to take this one more carefully than the last 2, because I don't think it's gonna be a hard question, but it's not my expertise, we'll say. All right. Looking in my formula booklet here, I'm definitely going to want to use this formula for conditional probability P of A and B over P of B. Now, if this is our target goal and P of B is something that I have, and P A and B is not something that I have. I'm thinking in order to finish this question, I'm going to need to find P of A and B, which means I'm going to look for another formula that has A and B in it, but also probably uses A's and B's and A or B's. So, okay, I think it's the top formula in the booklet there. I'm going to use the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And I'm using this formula because I have this, I have this, I have this. That's going to help me find it, and then I can plug it in there once I do that. So let's do this. The probability here is 0.7 is equal to 0.3 plus 0.6 minus probability of A and B. Should just be able to subtract these things around and move them, and just easy numbers here. That's going to make 0.9, and subtract that to the other side. That's going to make negative 0.2. Again, this is a no graphing calculator paper 1, so let's see if I can do this without. That's 0.9, and subtract that, that's 0.2. It's negative, and that's negative. A and B, it's negative, negative, so it's going to be a positive 0.2. Like I said, that's going to then go back up here. Probability of A conditional B is 0.2 divided by 0.6. That's going to be just like 2 divided by 6. It's going to be 1/3. The probability of A and B is equal to 1/3, right? Or I guess if these are all decimals, 0.333. What do we think about answer guide? We got that right? Yes. Not too bad. Not too bad. Just using formulas. Again, as soon as I noticed I was missing this one, looking for the other one. Oh, these are my favorite questions. I'm rewarded for doing stats by giving a graph of a derivative, my absolute favorite. The diagram shows the graph of f prime, the derivative of f. So this is the derivative. This is not f. I might even write on here just to make sure I'm clear. This is not f. I do not want to mess that up. The x-intercepts are b and d, of course. Minimum at a, maximum at c, of course. Write down the value of f prime of x at b. A part 1, f prime at b is equal to 0. Right? I mean, this is the graph of f prime, and here's b, and the value is 0. It says it's an x-intercept. So, wow, we love that. That's the easiest point of all time. Part 2. Verify that the x-coordinate of b is also the x-coordinate of the minimum of a graph of f. So remember, it doesn't look like a minimum, but that's because we're not looking at f, we're looking at the first derivative. How can we verify that it is a minimum? I can maybe do a little chart like this and say b, and before b, the graph is negative, and of course, before b, the graph is negative because it's down below the x-axis, and after b it is positive. And because we're looking at the first derivative, that means that my graph is, when it's negative, going down, and then after that it is going up. And that means that my graph looks like this, and that means that I have a minimum at b. This is a little first, I guess I need to do it a little bit better. Not quite sure how I can get all this together. I think that works fine for verifying that it is a minimum. I'm definitely going down before, going up after, and that makes it a minimum. And I think I feel pretty good about part 2. B, which of the points A, C, or D corresponds to a maximum graph of f? This is a 1 mark, so I think I just need to just tell them what the answer is to a maximum on the graph. This should be especially easy because we just found a minimum, and so we can just, keep the same pattern. If the minimum is here at an x-intercept, I'm pretty sure that the maximum is also going to have to be here at point D. It's the same thing, it's just opposite. Plus means I'm going up, negative means I'm going down. If you go from up to down, that means you have a maximum there. So I think all I'm going to write is D. That's a 1 mark question. I think we're good. C, verify that C corresponds to a point of inflection on the graph of f. Well, point of inflections have to do with the second derivative. And so what are we looking at? C here. If I'm thinking about the second derivative at C, that would be the slope of the first derivative, right? Because I want to elevate from this first derivative up to the second derivative, so I'm going to be looking at my slope. Maybe if I had a lot of time on the test, I might even write something like, looking at slope of f prime to find f double prime values, something like that, right? If I really wanted to make sure that I'm getting these little 3 marks here. The second derivative is the slope of the graph, and before C we are a positive slope, and after C we are a negative slope. That means before C we are positive, and after C we are negative. That, of course, when we're talking about the second derivative positive means concave up, and the negative means concave down, and that means that C is where we change from concave to concave, and that means we have a point of inflection at C. We could also, again, the more you write, we have this room. I think this is a point that we want to make sure we get. You could say, maximum and minimums of f prime are point of inflection on f double prime. And, just writing a bunch of things like this down that are all true statements just to make sure you catch those points. Be good. Oh, question 5. Easiest question ever. Next. A geometric series has a common ratio of 2 power x. Okay. Find the values of x for which the sum of the infinite series exists. This is an easy question, but I think it's might be one that people would kind of goof up. We need for the sum of an infinite series to exist. That means that we need to add up an infinite amount of things and have them exist, or have them not reach infinity. They need to approach a number. It says find the values of x, which means I need to find all the values of x. Surely it's not going to be by listing them. It's going to be a range, or I guess a domain, since x is the value. The way I'm thinking about this, x is a variable, x is an exponent. I'm saying the wrong words every time. X is the exponent, and if I have, let's say, a number like 1, that means that my common ratio is going to be 2, and then I'm going to be getting twice as big, twice as big, twice as big, twice as big, and this won't work. Let's say I have one like 0. That would mean r is equal to 1, and that would mean that my value would just stay at 2 forever. It would be 2 plus 2 plus 2 plus 2 plus 2 plus 2. Again, that won't work. Let's say I choose one like -1. That means my r is going to be 1/2, and this will work. If it's -1 and my r is 1/2, then my numbers are going to be shrinking. This is a super famous one where you could have 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, and here's my 1, and then here's my 1/2, and then here's my 1/4, and then here's my 1/8, and then here's my 1/16. And when you sum up this infinite series, you get 2. So surely I need negative numbers. -2 will also work. What if we try something like -1/2? That means that I should be r equals 1 over square root 2. Will that work? This is still a number that is less than 1, which means that number is going to be getting smaller than it was before. And so I think that this will also work. I don't have a calculator to double check, or at least a graphing calculator to double check. And so I still think that this does work. So I'm going to say, find the values for x for which the infinite series exists. I'm going to say that I know that its x needs to be less than 0. I'm trying to think now, what if it's less than 1, right? What if it is something in this range? What if x is equal to 1/2? That means that it would be the square root of 2, but the square root of 2 is still a number bigger than 1. The square root of 2 is like 1.4, so I would still be growing. So I think we got it. I'm going to box this up. I think x needs to be less than 0. It can't be equal to 0, because then it'll be 1 and we'll stay 2 forever. That won't work. B, if the first term of the series is 14 and the sum to infinity is 16, find the value of x. All right, so we're going to want to use our formula here probably. Back in the first unit, sum of the infinite geometric series. Now this does say the absolute value of r needs to be less than 1. Interesting. All right. That's what we were doing earlier. S infinity is equal to the first term 1 minus r. We are plugging in everything here. The sum at infinity is 16. The first term is 14. 1 minus r. The rate is 2 power x. It's not just a regular old r. It's 2 power x. Now I just need to solve this, so I'm going to go ahead and multiply this the other side. 1 minus 2 power x times 16 is equal to 14. I'm going to, maybe I'll distribute this. 16 minus 16 times 2 power x is equal to 14. I'd probably subtract 16 to the other side. Or, yeah, let's just do that. Negative 16 times 2 power x is equal to negative 2. I'd probably make both of these positive by multiplying by negative 1. Now, we have a little trick that we can do here. 16 is 2 to the power of 4. It's 2 times 2 times 2 times 2. And if we're going to multiply this by 2 power x, when we multiply things that have exponents, let's use like this as an example. What would this be? X squared times x cubed. Nice, x to the 5th, which means how do we add, or no, spoiler, we're going to add these numbers together. So here, I can make this 2 to the x plus 4 is equal to 2. And now, because these have the same base, I can set only their exponents equal to each other. I need the exponents of x plus 4 and the exponent of 1 to be the same. And you might be able to already spot what the answer is going to be. X plus 4 is equal to 1. And then I'll subtract 4. X equals negative 3. Oh, lost you a bit there. So I rewrote 16 as 2 power 4 so that then I could use my law or my rule about multiplying things with exponents in the same bases. Then, because I had 2 equals 2 with exponents, I knew that as long as the exponents were the same, we'd be good. So then I focused only on the exponents, and then I subtracted 4, and I got negative 3. How do these answers look, answer guy? Both of them? Okay, excellent. All right, we've made it to section B, long questions. So far, I'm feeling pretty good. We have done, what have we done? 27 minutes, and we got through the entire short section. Let's waste a little bit of time here. Let's count up the marks. I feel pretty good about 6. This was 7. Maybe there's a chance we didn't get our notation quite right here, or didn't quite write it the way they wanted, but still I feel pretty good about those 7. This one was 5. I definitely feel like we got this one right. Oh, we skipped a question. We skipped a question, but I want to do one of the long ones. All right, let's do this question really quick. How did I skip this? Fast. Let n and n plus 1 be any 2 consecutive integers. Okay, so that means that they are integers for sure, no fractions, not counting anything irrational. Hence, prove the sum of the squares of any 2 consecutive integers is odd. Okay, so we're just talking about 2 numbers that are next to each other, and we're going to square them, and we need the sum to be odd. Well, if we have n and n plus 1, that means one of them is even and one of them is odd because they're next to each other. So that is for sure. So let's say that we pick. Let's say assume n is even. If n is even, then that means that n squared is equal to n times n. And when you square 2 even numbers, you should always get an even number. So, if we have, 6 times 6, that's 2 times 3 times 2 times 3, and these will always make pairs. If n is even, that means that n can be divided by 2. And if n can be divided by 2, has a factor of 2, once we multiply all of its factors together, that means it will have a 2, and it will be even for sure. So let's write that down. Assume n is even. N has a factor of 2. N squared has a factor of 2. N squared is even. All right, so n squared is even for sure. Then let's talk about n plus 1. let's say, assume n plus 1 is odd. Well, that means that n plus 1 squared, let's say that n plus 1 does not have a factor of 2. N squared plus 1 does not have a factor of 2. That means that n plus 1 squared does not have a factor of 2. That means that n plus 1 squared is odd. All right, so now we've proven that after we square them, we're going to have one that's even and one that's odd. And we need to prove that the sum is odd. So now what we need to prove is that an even number plus an odd number is odd. N squared is even, n plus 1 squared is odd, and if you add an odd number to an even number, it's odd. Do we need to prove that? Summing one even number and one odd results in an odd number. That's just the truth. In order to sum numbers and get evens, you have to do even plus even or odd plus odd. But if you have two different ones, you will get odd. Now, we do want to be careful before I finish. I'm not sure if I'm getting all my marks for writing this, but I think I'm getting quite a few marks here. At the beginning, we have assumed that n is even and n plus 1 is odd, and it could be the other way around. So at the end here, I just want to make sure I make a comment like, proof is the same if n is odd and n plus 1 is even. Again, I'm not sure if I'm getting full marks on this question for these proofs. You know, there's some ways you can maybe be a little bit better practiced and really try to nail down all of these marks, but I feel like we said enough here to be on the right track for the most part. Cool. All right. Oh no, we didn't do it as fast as I wanted. All right, let's get to the back here. You guys want an extra sheet of paper? Still got a little stash. All right, 1.5 minutes, and maybe we'll push a little bit past when the timer goes off. 35 students, that one looks like the number of students who study both. That looks like probability. This question down here looks like calculus with derivatives. Ooh, looking like a little bit of a derivative brain teaser there. And this last one that we have, function g, this looks like derivatives and integrals, and this as well. Let's choose the shortest one because we're already pushing our 35 minutes. Let's look at 7 here. I just grabbed all those papers. What did I do with them? In there. All right. All the students in a class of 35 must study at least one science, either biology or chemistry. Some students study both. 25 students study biology and 15 students study chemistry. A, part 1, find the number of students who study both biology and chemistry. Well, we think about Venn diagram here. We think about biology versus chemistry. In the biology, we have 25 kids, and in the chemistry, we have 15 kids. Oh, we're over time. Now, we know that total, there are 35 kids only, and they have to study biology and chemistry. There's no kids outside of here. Well, the problem is that 25 plus 15 is not 35, it's 40. So we have some students double counted. And so I think it's going to have to be more like 20, 10, and 5. This is going to put 25 kids in biology still, 20 and 5. And this is going to put 15 kids in chemistry, 5 and 10. So I think it's going to be the number of students who study both biology and chemistry, biology and chemistry is equal to 5. Write down the number of students who study only biology. Oh, nice. More free marks. We love this. Part 2, only biology. Biology and not chemistry, which you can do with this little hyphen thing, is 20. If you don't know this little language, then just write out only biology equals 20, whatever. A student is selected at random from the class. Find the probability that a student studies only one science. So now we're going to do this, and we're going to do probability. The probability is going to be a fraction, less than 1. So how many total students are there in the class? 35. And the probability that they study only one science, that would be the 20 kids from biology and the 10 kids from chemistry. And that would be 30 over 35. And since this is no calculator, I'm probably just going to leave my answer like that. That's part 1. Part 2, given that the student selected studies only one science, find the probability that the student studies biology. So this is a given, meaning this is going to be a conditional probability where we know that our starting setup is not the full class. Our starting group is only a subgroup of that class. And so the conditional, the easiest way to think about the conditional probability is that it's going to change how many kids you're choosing from, which means it's going to change your denominator. So my probability here, if I wanted to write it, I would write it like, this is the probability conditional that the kid is in B, is in 1. I don't know. It's hard to write like that, I guess. We'll just write it like this. The probability would be 30 on the bottom this time, because our denominator needs to be the number of kids that we're choosing from, and they only study one science. 30 kids only study one science. Then the top, find the probability that the student studies biology, would be 20. I am noticing that these are very simplifiable fractions in an easy kind of way. So this one would be 6 over 7. This one would be 2 over 3. I'm not sure if I'm getting more credit for that or not. So far, that's 8 marks, pretty quick. Let B be the event that a student studies in biology, and C be the event that a student studies in chemistry. Okay, nice, we're using those same letters already. Show that B and C are not mutually exclusive. All right, let's go. All right, I see a formula that is literally called mutually exclusive events. So C, mutually exclusive events says the probability of A or B is equal to P of A plus P of B. This is straight from the formula booklet. It's called mutually exclusive events, so that tells me it's probably going to use it. And I need to prove that it is not mutually exclusive. That is probably because that the probability of a student being, let's rewrite this using B or C, because that's the question that they want us to use. Sorry. Rewriting it with B and C, the probability that a student is in biology. Let's see, what does it say? The probability for a student to be in biology is 25 out of 35, and the probability that a student is in chemistry is 15 out of 35. And if we add those up, we get 40 out of 35. 40 out of 35, also 8 out of 7. This is a number that is greater than 1. You cannot have a probability greater than 1. And so this is going to be impossible. All right, probability greater than 1. Impossible. And let's get our last question here, D, so that they are not independent events. Yeah, we got another formula there. Independent events for part D, another formula called independent events. A and B is equal to the probability of A and the probability of B. Gonna rewrite this using B and C. And I don't see why I can't do the same thing again and just multiply these, actually plug them in. Probability of B and C is equal to the probability that a kid is in biology, 25 out of 35, and the probability that a kid is in 15 out of 35. Multiply these together. It's not too hard to multiply together without a calculator. This is 5 times 5 times 3 times 5. If I think about their prime factorization. 7 times 5, 7 times 5. Cross out some of the 5s. This is 15 out of 49. But that doesn't prove anything. How many marks are we getting for this one? This is a 3-mark question. I do not think that we've actually solved this question yet, because I don't see why this doesn't work. It says prove that they are not independent events. I believe that's because we already, maybe we can just use our results from A up top. The probability that a student is in both, we've already figured that out. The probability should be 5 out of 35. Right? This is our result from question A, or part A, 5 out of 35. And this is our result using the independent events formula, and they are definitely not the same. And I think that's good. How do these look, Weapons Master? For the first part, I got part 1 is 5, part 2 is 20. For part B, I got 6 out of 7 for part 1, 2 out of 3. For part C, I said, well, the probability is greater than 1. That can't happen. Excellent. And then down here, I got that these two numbers are not equal to each other. The one from part A, 5 out of 35. I'm not so sure if this one gets marks. Maybe we'll get a couple marks.
Yeah, that's not right.
Okay, well, maybe we goof this. Again, when it comes to this, getting 10 out of 13 marks, I'm certainly happy with that.